Hey QE decoders, Michael L. Perry here. There's an assumption that we use when we build software that's really ingrained. It's built into almost every programming language that we ever use to create software. And that's the assumption that if I have a variable and I store a value in that variable, then when I come back later, I'm going to be able to read that same value out of that variable. It's an assumption that I call locality. You can see this assumption in an object-oriented language when you see that an object has fields, it has data members, and the methods act upon those data members. You can see this assumption in a file system, where if I store information in a file, I expect to be able to read it back out. You can see this assumption in a database. If I store a value in a column, then I expect that column to have that value next time I read that row. So this assumption is baked right into almost every programming language that we use. And that's understandable because the assumption itself comes from the definition of computing, which is the Turing machine. In a Turing machine, we have a tape, and each cell in the tape can record a symbol. And so the processor comes along and it writes a symbol in one cell of the tape, and then later it could read that symbol from that cell of the tape. It's also built into the von Neumann architecture, the architecture by which all digital computers are designed. And that's the architecture that I have a set of memory and a processor that can read and write values in that memory. So locality is pretty deeply baked into our assumptions, and that's pretty much how we write software. But what if you didn't have locality? What would you be giving up, and what would you be gaining? What's the alternative to locality? That's location independence. Location independence means that when I have a resource, the identity of that resource is independent of where it's stored. In a lot of languages, we use pointers, actual memory locations, to identify the object that's there. But location independence means it has identity no matter where I've stored it. It also responds to queries in the same way. So no matter who's observing the object, when they observe its state, they're going to get the same information. It also responds to commands in the same way. So no matter where I'm issuing the command and in what order, the result of all those commands is going to be the same. So identity, queries, commands, these come together to form the behavior of a resource, and if that behavior doesn't depend upon location, then we have location independence. So how is it even possible for a resource to be location independent? Well, historical modeling provides location independence in three different ways. It provides location independence of the queries because facts are immutable. No matter who is querying the fact, at what time, in what location, they're always going to get back the same answer because the fact itself doesn't change. It also provides location independence of commands because the commands are partially ordered. Because I can issue a command in one location and then a different command in another location, then I don't know which command is going to be received first. And finally, historical modeling provides location independence of identity by simply defining the identity of a fact to be its immutable state. So every observer sees the same state, therefore they see the same identity. Now don't get me wrong, locality is valuable. So let's take a look at a few of the things that locality gives us that we can't have if we have location independence. So, for example, last time we talked about auto-incrementing IDs. In order to auto-increment an ID, I have to have the most recent ID that I've allocated in a location. And then in order to get a new one, I have to be able to go to that location, increment it, and then use that new value. And so if I've got a web application where I perform some action and create an object on the client, in order to use the auto-incrementing ID for the identity of that object, I have to go all the way to the server where that location is stored. And then when I come back, now I've got the new ID. There's something else that we talked about last time, and that's uniqueness constraints. For a uniqueness constraint to be enforced, I need to have complete information. All the information, all of the rows, need to be stored in the same place. And then I can check all of those rows to see if this new row that I want to insert is unique in some respect. So in order to have that completeness of information, I have to have locality. It has to be stored in some location. The third thing that we use locality for is locking. So if you've ever used a version control system that's based on locking, then when you need to change a source file, you will lock that file, and nobody else will be able to change it while you've got it locked. Then you make your changes, and you check it in, and that unlocks the file. Now, in order for this kind of version control system to work, there has to be some central repository, some one place that everybody goes to in order to lock files. The Git version control system, on the other hand, does not have a central repository as part of its definition. It's location independent. And so it doesn't allow locking of files. So you can see these are all very valuable things, but they come at a cost. If I need an auto-incrementing ID, then that means I need to wait for the server to respond with that new identity. And so that means I can't have low latency. If I need the uniqueness constraint to be enforced, then that means that I have to perform that operation against the server, and I can't be autonomous. And if I need locking, that means there needs to be some central location that can hold that lock. And so I can't have temporal decoupling, where different things can happen at the same time, and we're not waiting on each other. So on the one hand, you've got some value that's provided by locality. And on the other hand, you've got some value that's provided by location independence. So how are you supposed to choose? Well, by default, today, we tend to choose locality. What I challenge you to do is to change your defaults. By default, choose location independence, but then explicitly when you need it, make the deliberate decision to choose locality. Then I think you'll end up with a much better balance. You'll get some of these benefits when you absolutely need them, and then when you don't, you'll default to these benefits over here. Now, one of those benefits, temporal decoupling, I want to visit in a bit more detail in the next video. So, come on back.